Welcome, Calculus. You're going to take notes on drawing graphs based on limits. There's no new techniques here. It's just putting things that we know about limits together and seeing if you gave me some information about a graph, if I could sketch a graph with those properties. So pause the video, take a minute to draw down these properties, all four of them, and we're going to try to sketch what a graph would look like that has these properties. Thing to know is that these properties there's a billion different ways I can draw a graph with these properties. But I'm just going to come up with an example that fulfills all four of these. So number one on the checklist, f of -1 equals 3. So that means the point -1, 3 is on the graph. So if I go to -1 and up 3, we have the point f of at -1, the value is 3. So we can check that off. Now I want the limit as x approaches -1 to be 1. What that means is as I approach -1, which is right here, this is x is -1. I want the height of the function to be approaching the value 1. So I wanted to approach this value. Now I already have a value here, so I can't actually have a value here as well. So that means there's going to have to be a hole here. But I'm going to approach it from the left and from the right. So if I come from the left, I got to, my function can be doing a lot of different things, but I got to come to that point. And as I'm approaching -1 from the right, I also got to make sure I come to that point. So now the limit as x approaches -1 is 1. Now I want f of 3 to not exist. So at 1, 2, 3, I can't have a point here. So I can either have a hole or I could have an asymptote. Doesn't matter which one. I'm just going to put a hole here. So f of -3 does not exist, but the limit as x approaches 3 is infinity. So that means I can't do what I did here. If I want the limit to go to infinity, that means from both the left and the right, I need an asymptote there. So it's going to positive infinity. So I'm going to erase that hole because this property here tells me that at 3, I need my function to be going to infinity from both sides because it's not a one-sided limit. So this function that I just drew right here, and whether you put arrows on it or not, you can go through this checklist again. F of -1 is 3. We see that here. As we approach -1, the value is 1. I see that here because that's 1. F of 3 does not exist. That's correct. And the limit as we approach 3 is going to infinity. So all of these things were obtained. All right, another graph. Pause the video, copy down the properties, and we'll begin. F of -1 and f of 4 are 7. So -1, 7 and 4, 7 are both on this graph. So at -1, the output is 7. 1, 2, 3, 4, 5, 6, 7. And at 4, the value is also 7. So at x equals 1, 2, 3, 4, we go up to 7 again. So we can check that off the list. Now f of 3 does not exist. So at 1, 2, 3, so I can't have any points go through at 3. So we might have a hole there, we might have an asymptote there, I don't know. So just remember, don't put a point at 3. The limit at 3 also doesn't exist. So I could either have a jump, I could have an asymptote, but I can't have a limit either. So if I had something like this, yeah, f of 3 doesn't exist, but the limit would exist, and I don't want that to happen. So, maybe I have an asymptote here, and maybe I'll start it at that point. And then maybe I'll put a hole here. So right now, f of 3 does not exist as we wanted, and the limit as x approaches 3 does not exist. Right? The right is going to infinity, the left is going to 1, 2, 3, 4, it looks like. Now, as x approaches 3, I want the limit to go to infinity. So that changes what I have to do now. So as we approach 3, I want it to go to infinity. That means from the left and from the right, I want it to go to infinity. So I have an asymptote here. So that allows me to check off this box. Oh, excuse me, from the right. From the right, it's going to infinity. It already was. So what I had here wasn't wrong. From the right, it is going to infinity, so we're good. From the left, it doesn't tell me what x is doing as the function approaches 3 from the left, so I don't need to make it go to infinity if I don't want it. Now the limit as x approaches 4 is 0. So as we approach the x value 4, the function needs to approach 0. So this right here, I need to make sure that happens. Okay. So I'm going to put a little hole here. Because f of 4 is already defined, I can't put a point there, but as I approach this value, it needs to be approaching 0. So whatever's happening over here doesn't matter. And whatever's happening here still needs to come there. Now I also know I need to go to infinity, so it's going to look something like that because of this property right here. So that's why we're going to go to infinity still. So now as x approaches 4, the limit is approaching 0. So that is checked off. So now I can kind of do whatever I want with this thing. I don't know, maybe go through that point and shoot out. It doesn't matter. I could have done whatever I wanted to. All the properties are still in place. And the last one, pause the video, copy the properties down. All right, f of 0 is 4, so 1, 2, 3, 4. That point is on my graph, no problem. As x approaches 0 from the left, it's going to negative infinity. So that means as x approaches 0 from the left, we're going to negative infinity. Okay, so that's going to have to happen. As we approach negative 3, we're going to negative infinity. So, okay, so there's an asymptote here. And as we approach negative 3, 1, 2, 3, I have another asymptote here. And that's going to negative infinity from both sides. So from this side, we're going to negative infinity. And from that side, we're going to negative infinity. So now the limit as x approaches negative 3 is negative infinity. Perfect. As x approaches, the limit as x approaches negative infinity, the value of the function is 0. So this, as x goes to negative infinity and infinity, these are end behaviors. So as x goes to negative infinity, the height of the function is approaching 0. So that's a horizontal asymptote. Right, so as x goes to negative infinity, the value of the function is going to 0. So I'm just going to have this thing come up right here. And as x goes to positive infinity, the height is also going to 0. So I know that f of 0 is 4, and I'm just going to start from here. And as I go to infinity, the height of the function is approaching 0. So that takes care of both of those properties. So replay it. We'll get some more practice in class, but hopefully that helps. Have these in your notebooks. I'll look at them, give you the grade for them, and then we'll get some more practice. All right, have a good one. Bye.